the ground term, and then probably what we mean by the ground term is that the term of the lowest energy. That's what the ground term means. The term of the lowest energy. Looking at these terms, we should arrange them in their increasing order. The way their energy increases, there are laws. There are 3 laws guiding this. To do this perfectly, there are 3 laws guiding it. Law number 1. All the laws, you can generalize it to be something like this. Something like this. You know, the bigger in inorganic chemistry, atomic size increases down the road. So the bigger, number 1 rule is the spin multiplicity. Spin multiplicity rule. Spin multiplicity rule. That says that the bigger the spin multiplicity, or the higher the spin multiplicity, the lower the energy. So 3, 1, 1. Of course, this is 3 is bigger than, so this is lower than these 2. Right? The second rule is the rule of, L value. L, or we call it greatest L value. Like we said, the bigger you are, the lower you are in energy. That is the truth. There are 2 people on the sprint. One is very huge, like Yokohama. The other one is fit. The fitter one will have more energy to run than the bigger one. So the bigger the L value, the lower its energy. The bigger the spin multiplicity, the lower the energy. So the bigger the L value, the lower the energy. Now, looking at this, we know we have to consider the spin multiplicity first. That's why we chose this. Although it is not always correct. Sometimes the practical, real life situation is a little bit different. But that is within systematic error. It is acceptable. Alright? So the greatest L value between D and S, which one is greater? We have S, P, D, F. 0, 1, 2, 3. D and S. D is greater than S. So D is lower in energy than S. So that means that this is 3P lower than 1D lower than 1S. Lastly, there is another rule, which is the last rule. At times, in fact, in this case, we have not actually derived the full term symbol. If you derive the full term symbol, like in some cases, in fact, even if you were not told in any question, you should finish it. And if you are told, you should always do it. Full term symbols. We have our spin multiplicity from our previous classes is 2s plus 1 Lj. This is the way full term symbols are. Right? This J is called Saunders coupling. Saunders coupling. Now, we are not done with this. Why? Because of the spin multiplicity. Right? Of the spin multiplicity. We are not done with this because of the spin multiplicity. Which is what? This is more than 1. It's 3. So you can still split it. You can still split this P. How do we split it? If we use this rule, multiplicity, of course we've gotten the multiplicity to be 3. It has to have J value. And for all J value, we have L plus S. J value is a value of, it's a range of number, which are the first of the data is L plus S. The second one, L plus S minus 1. And the last one is L minus S. Right? For cases where you have 3. Now for this case now, alright, we've got to get the L value. The L value for 3P, the L value SP 01 is 1. The S value, to get it, it is known, this is the formula, and it is equivalent to the multiplicity. So that means 2S plus 1 equals to 3. Mathematically, S equals to 3 minus 1, 2. Divided by 2, that is 1. So the J value will now be equals to, our L is 1. 1 plus 1, comma, 1 plus 1 minus 1, comma, 1 minus 1. And that will be 2, alright? 1, 0. We are not going to be interested in finding the J value for this guy because it is just having a spin multiplicity of 1. There are one of these. From what we did from here, we had only 1 T. Alright? We had only 1 T. And we have 3P. Because we have 3P, that's why we are trying to look at the J value of each of the P's. Because there are 3 P's. 1 P has to come before the other. Alright? So, if you have 3 P's, how do we then create them? How do we order them? How do we put them in their places? They are of this value. The J value is this. Alright? It means that one of the 3P is 3P, 2. The other one is 3P, 1. And the last one is 3P, 0. Because there are 3 of them. 2, 1, and 0. For the J value. How do we place them? It's quite easy. It's quite easy. Like I said, which one is the lowest in energy level? That is the third law, the third principle. To arrange them in increasing energy level. Principle number 1, spin multiplicity. Greatest L value. Principle number 3 is the J value. This J value is the addition of the spatial orientation and the spin. The spatial orientation and the spin. And when you say something is spinning, it's disorganized. Is what? Is disorganized. Now, the higher the disorganization, the less stable it is. The more the disorganization, the more stable it is. The higher the disorganization, the more stable it is. The higher the disorganization, the less stable it is. Something, you are considering 3 states of water, of H2O. You have the solid phase, you have the liquid phase, you have the gaseous phase. The least stable is the gaseous phase, isn't it? Because it is the most disorganized. Now, this is the most disorganized. This is the least disorganized. The least disorganized is the most stable. It means that this 3P naught is less than 3P1, less than 3P2 in terms of energy. Then less than 1D, less than 1S. So, how we can understand this? If anything wants to go wrong, just look at this example that I gave you. This J value is a function of destabilization. Something that is destabilized. Do you understand? The higher the value, the higher the destabilization. Gaseous. Alright? Somebody that is jumping, jumping, and somebody that is seated calmly. Which of the two has the higher energy? The one that is jumping. That is the one that has highest value of the J value. It means that this one is higher in energy than this. So that is that. And lastly, ground term symbols. Like we noted, ground term symbols, which is the last thing from the items. Now we have ground term symbols, which is the last. Of course, it's basically usually we are considering coordination compounds. Most times we're talking about transition metals, whether main, whether minor. Alright? So we'll be really interested in those of D orbitals, D configuration. Alright? So to do that, to exemplify that, let me use it as example 2. Find the ground term of titanium 2+. Real life question. Titanium 2+. I'm going to add the link to one of our classes where we gave you mnemonic device on how to memorize atomic number of transition metals, STV, crew, and so. So from that, you can see that titanium is atomic number 22. An element above argon, to write the electronic configuration, is the argon core 18, then 4s2, that's 20 for 22, alright, 3p2, STV, 21, 22. Or let me use STV crew, let me use chromium 3+. STV crew 21, 22, 23, 24, 18, 20, 24. Find the ground term of this free aeon, of this metallic aeon. The easiest way, there are 4 steps. Number 1, sketch the diagram. We've written the configuration and we've discovered. But since it is 3+, what does that mean? Excuse me. What does that mean? That simply means that it has lost 3 electrons. So it's a D1. Alright? It's a D1. It's a D1. So meaning that we have a D1 in place. If you have a D1 in an octahedral fluid, D is usually split into T2G and EG. When we get there, we exemplify it. So this is, since it is 1 electron, that is the way it is. Now to find the ground term, this is the first step. The second step is to do what? Is to find the spin multiplicity. Each of the terms, spectroscopic term, has multiplicity 2s plus 1 and has the J value. So we want to look at the spin multiplicity. The formula to do that for the spin multiplicity, alright, for the spin multiplicity, what do? What you do is to count the number of unpaired electrons. In this case, it's 1. Then add 1 to it. 1 plus 1. That is 2. Right? That is 2. Are we there? That is 2. So the spin multiplicity is 2. Step number 3 is to find the L value. This is a D orbital. And D orbitals have 5 rooms. +2, +1, 0, -1, -2. These are the labels of the rooms. Now the electron is only in +2, +2, +1, 0, -1, -2. And we are in need of the L value. Just like when we did when we were doing microstates. To get the L value, we usually multiply the value times the number of electrons. And because there's just one electron, the L value is 2 times 1. That is 2. What value of 2? What does 2 correspond to in L? L and the value. If you recall, when it is 0, it is S. When it is 1, P. When it is 2, it is D. So since we have D, 2, so that corresponds to D. So the ground term is 2D. The spin multiplicity 2 and the spectroscopic term G.